Elon Musk's plan for robots to shape our future has captured the world's attention. It promises a perfect world where humans and machines work together. However, beneath the impressive surface of Tesla's Optimus project, serious concerns and unanswered questions remain. As Tesla pushes the limits of artificial intelligence and robotics, critical issues are being overlooked. What hidden dangers and unexpected problems are being ignored in the rush to create a better future? The Optimus robot, also known as the Tesla bot, was first announced by CEO Elon Musk during the company's Artificial Intelligence or AI Day on August 19, 2022. At the event, he introduced the concept of a general-purpose humanoid robot designed to assist with tasks that are dangerous, repetitive, and boring. The initial presentation featured a human dressed in a robot costume, illustrating the vision for this project. In September 2022, Tesla unveiled a working prototype of Optimus at AI Day 2022, demonstrating the company's progress in robotics and AI integration. Since then, Tesla has continued refining Optimus, showcasing improved versions like Optimus Gen 2 in December 2023. Most recently, in October 2024, during Tesla's We Robot event, robots were demonstrated performing tasks such as serving drinks and interacting with attendees. The company aims to begin limited production of Optimus for internal use in 2025, with plans to make it available to other companies by 2026. Tesla designed the Optimus robot with human proportions in mind, intending to mimic human tasks. Standing approximately 5 feet 8 inches tall and weighing 125 pounds, the robot resembles a person in both stature and structure. It has a sleek monochrome appearance, with a mostly white body accented by black joints, hands, and head. The decision to make the robot bipedal allows it to navigate environments designed for human access, such as doorways and staircases. This configuration adds practicality in both home and industrial settings. Optimus utilizes an advanced visual navigation system similar to Tesla's autopilot technology, equipped with multiple 2D cameras and advanced neural networks. It can recognize objects, identify obstacles, and create a 3D map of its surroundings. This capability allows it to maneuver autonomously, avoiding obstacles and ensuring smooth movement. It even adapts to changes in its environment and can navigate unfamiliar spaces without GPS. The robot's ability to avoid both static and moving objects such as people makes it ideal for dynamic workplaces like factories. One of the robot's more practical features is its autonomous charging capability. It is designed to locate and dock with a wall-mounted charger when it needs to recharge. This feature allows for continuous operation without human intervention. After recharging, the robot can unlock and resume its tasks independently, enhancing productivity. This function is essential for environments where robots must work 24/7, such as manufacturing facilities where downtime can be costly. The robot is designed to handle complex physical tasks. It has the dexterity to grip, carry, and manipulate objects. Its hands feature 5 fingers, enabling a secure grip on various tools and materials. Optimus can carry and hand off items of different weights and sizes, showcasing its potential for use in labor-intensive settings. Optimus incorporates self-learning technology, meaning it can improve its performance over time by recognizing patterns in its actions. This AI-driven learning is crucial for performing repetitive tasks in dynamic environments. The goal is to develop robots that require minimal reprogramming and can autonomously learn and adapt in real time. This advancement would make them ideal for various applications and potentially even home environments in the future. While still in development, Tesla envisions Optimus as a versatile robot capable of performing both household chores and industrial tasks. In homes, Optimus could handle tasks such as carrying groceries, tidying rooms, and even assisting elderly individuals with physical tasks. In industrial settings, Optimus is well suited for repetitive or hazardous work. Elon Musk aims to make Optimus a widely accessible tool with a target price of around $20,000 to make it affordable for both companies and potentially households. This pricing strategy reflects Tesla's vision of creating a mainstream robot capable of performing everyday tasks. Although the initial price may be higher during early production phases, Tesla's long-term strategy involves scaling manufacturing to reduce costs, making humanoid robots accessible to a broader market. Despite the excitement surrounding its potential, the current version of Optimus shows that it is still far from replacing human labor in everyday scenarios. This suggests that the robot currently lacks the decision-making abilities and independence needed for complex tasks in unstructured environments, such as household chores or caregiving. While Optimus has demonstrated physical abilities such as dancing and lifting objects, the complexity and variability of real-world tasks like handling items of different sizes and weights pose significant challenges. Manufacturing tasks where Optimus could initially offer the most value still require robots to navigate tight spaces and work with diverse materials. Moreover, it lacks the fine motor control necessary for tasks involving delicate manipulation. Power management is another challenge for humanoid robots. Although Optimus reportedly has a battery that supports several hours of operation, industrial environments or household chores often require longer periods of use. This means it would either need frequent recharging or significant advancements in power storage technology to become viable for continuous operation. Without these improvements, Optimus's usefulness in high-endurance settings could be limited. Integrating robots into daily life raises ethical questions and safety concerns. As Optimus' capabilities expand, ensuring it can interact safely with humans without risking harm will be essential. The idea of a humanoid robot performing household or caregiving tasks also brings concerns about security and liability in cases of malfunction or unintended action. Regulations and ethical guidelines for deploying such robots are still evolving, and public acceptance will depend heavily on assurances of safety and reliability. There are also privacy concerns given the advanced sensory capabilities of such robots, including potential use of cameras and microphones. These devices could record and analyze environmental data, raising fears that personal information might be collected inadvertently in homes or workplaces. Additionally, the reliance on remote human operation, as seen in Tesla's demonstrations, introduces potential vulnerabilities. Remote access could expose the robots to hacking or misuse. Tesla has yet to provide details on data security measures or clarify how it will handle data collected by the robots, adding to public apprehensions about privacy. With its anticipated price, Optimus will likely be out of reach for most consumers, at least initially, posing a barrier to widespread adoption. Tesla might prioritize industrial clients who can absorb higher costs in exchange for efficiency gains on factory floor. However, large-scale deployment of Optimus across industries could lead to job displacement, raising economic and social concerns. Although Tesla has acknowledged these challenges to some extent, broader discussions are needed on the potential impact on employment. Optimus could replace workers in many manual labor roles, threatening the job security of employees who depend on these positions. Will this robot ultimately benefit or harm humanity? Only time will tell. If you're curious and want to explore more intriguing topics, don't forget to check out our channel. We've got plenty more to discover.